Alright, so hello and welcome. Trying to conserve my voice a bit here, but struggling. um, Random flip matrix here on LeetCode, and we've already, excuse me, already solved this one, or I've already solved this one in my mind. I looked at this a while back. I just wanted to finally come back on some of these problems and solve them. So I'm not gonna speak too much. And by n binary grid matrix, all the values set to zero initially. Design an algorithm to randomly pick an index ij where matrix ij is 0, flips it to 1, all the indices ij where matrix of ij is 0 should be equally likely to be returned. Optimize your algorithm to minimize the number of calls made to the built-in random function of your language. Optimize the time and space complexity. So what I decided to do, if I can explain it, could basically convert the matrix binary grid into a single array. And what we're going to do is when we randomly select, like, hi, hey, let's go, Molito. Welcome, howdy. My voice is gone, so let me actually turn up. I'm just turn this up a bit so you can hear me. Yeah, my voice is gone, so I'll be kind of whispering. I think I'm kind of sick. But yeah, I've already solved this problem. We're going to convert this to just an array, and we're going to convert indices back and forth between the array and the matrix. And what we're going to do is we flip the index to a 1. What we're going to do is we're going to swap that. It's going to be an array of integers, and the integers representing the position of that particular index. And we're going to move, if we flip to 1, we're actually going to move it to the right side of the array, and have an index, a counter on that's going to tell you how large the array is. And so we decrement the array, so it's sort of like basically splitting the array into two pieces. The left side are still zeros, the right side are ones. And so then we can randomly select one of the numbers in this range to flip, and so that'll give us equal probability of all the possible selections, and it'll also allow us to satisfy what they're looking for. So it'll be one randomization call per bit per number, and also yeah, we can flip accordingly. And reset. Reset's pretty easy, actually. Reset, you don't even need to build the array. Excuse me. You can just take your pointer and slide it all the way to the right, the one that's supposed to represent the values that are have been flipped to 1. Now the tricky thing is, what are the outputs supposed to be? What do we return when we flip? Oh, we just return the random index. Yeah, that's fine. So I'll show you how to do this. As mentioned, I've already thought about this problem, understood. We're going to use array. We're going to not use too many characters. So m is the number of rows, and actually I don't need to do this. Whoops. think it's just n by n. Yeah. There's a fun routine we can use here that's useful. It's called iota. I don't know why it's called iota, but that's what it's called. And what it does, it'll fill your list with numbers. Each value will increment by 1. So iota from -4 in a list of 10 elements, you'll get -4 up to 5. Yep. I think that's all we need. Just thinking. Yep. One-dimensional array. Flip. We're going to say. Oh, we do need another thing here. Random device. How long are we doing on time? 6 minutes. Okay. Let's see how long this takes. Something like this. I'm actually not sure about this one. Oh, okay. Hmm. 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 Okay. Hmm. We can use the equal operator here. minus seed value. Oh, that's interesting. Huh. That's one way of doing things. I guess you could do it that way if you really wanted to. I always get that wrong too. That's confusing. Uniform int distribution. Yeah. Nope, that's not what I'm looking for. Excuse me. The param. I don't want to create a new one every time. It's param type, that's what it is. How are we doing on time here? 13 minutes now. Oh, okay. Alright, compiles. Neat. So. Okay. So I have our distribution. And now what we're going to do is have internal state as well. Int flipped. And this will be 0 initially. So flipped, we're going to start it. We're going to move it to the right side. It's going to be m times n minus 1, which is the array size minus 1. It's actually going to be our next flip, I guess. Let's do it that way. So everything to the right of next flip is flipped. Okay. So we're going to say from 0 to next flip. Excuse me, including next flip. We just have to double check that this is inclusive. Yeah, B, it's an inclusive closed interval. Okay, so that's what we want. That's what we want, and we're going to say x value, or just x, is going to be this dot params of p, x equals dist of gen, and then we say target is going to be array of x. Ret, we'll call it. This is going to be target. I think you divide by, so converting an index from one-dimensional to two-dimensional, you would, there's a row and column. So the row is going to be, I think, divide by, so we need a row and column amount. And we can say n rows, n columns is probably better. And so we're going to say is, one of these is modulo and one of these is divide by. So the column is going to be modulo the so target to get the row, and you would divide by, I think, the number of columns, right? So if you had 50 and you had 100, excuse me. So 10, if you had 10 by 10 and you had 50 in the middle, 10 rows, 10 columns, 50 is going to be the first 40, so the first 4 rows will be the first 40, and then really 0 through 9, so if you have 0 through 49 would be the first 5 rows, 6th row is really where 50 would be, and it'd be the 0th column. So you would modulo, excuse me, another question is, why? You would, well, yeah, you would divide by the number of columns, I believe, and you'd modulo the number of columns as well. I think, is that how it goes? The number of columns is the size of the row, and the number of, and then, yeah, actually what's left over is how far you are in. Is that right? I think that's all you need. Let me think about that for a second. Yeah, you would just, to go the other way from, so just to check it, you would say, row times the number of columns plus the column, that gives you target divided by number of columns times the number of columns plus target modulo number of columns. It should be the target. Yeah, because this part, this is integer division. So this remainder here is this part. Yep, I think that's right. Maybe I should practice that a little bit more. What this is going to do is we then swap the target with next flip, and then we decrement next flip. And one of the issues is there's always going to be at least one free cell, yeah. Won't check. Yeah, we won't check. We won't check that. But we could check that too. Make sure so we could throw an exception if you try to flip and there's nothing left to flip. Yeah, and then resetting, you just say just param becomes excuse me, uniform int distribution param type. We just make that 0 number rows times number columns, and then we set next flip is array.size -1. We just start over. Actually, you really don't even need to do that because you do that in every flip. Something like this is all you need. Yep, there you go. Done. 1,000 calls to flip and reset. What is this 3-1? Let's do like M and N could be 10,000 each. Whoa. Uh-oh. Wow. Is that okay? $100 million? Will that work? I don't know that that's okay. Oh boy. Let's do this a few times. Hmm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, let's try that. Okay. That should be fine then. Let's try it. I hope, actually. Oh. I was gonna say, wait a minute. I just realized that I really didn't test for, there are a few test cases that I kind of forgot to try. Uh-oh. Yeah, I made a mistake. I made a big mistake. I did this wrong. I did this wrong. Should have tested more. There we go. Okay. How are we doing? 25 minutes? And I thought about this so much before too. Not only did I get it wrong, but it's also very slow. Hmm. Hmm. Something tells me this is not the best way to do this. Really? Alright, I'll take it. That's fine. I don't think we really need to do much better than this. We could consider something else, but... Man, can't believe I got it wrong though. That's so annoying. I kinda goofed. Here. Yeah, that was bad. That was bad. Alright, well, what are the better options? Reservoir sampling? Hmm. What are the responses? I don't know about this. I don't know if they're all equally likely to be picked. Yeah, I didn't do this. Huh. Okay. Excuse me. Oh, you know what? Part of the problem is you don't actually need to use all of the elements in the array the way that I had. As it turns out, you have don't need to use all the elements in the array. As it turns out, you only have 1,000 at most actual executions. So actually it would be more efficient to use the unordered set. Actually, it was my mistake. I see the problem. I see my problem. You actually shouldn't use the array in this way. You should use an unordered set and just keep randomly selecting things until you get something that's not in the set already. Or you can just linearly traverse until you find something. It won't necessarily be constant time per item. That's interesting. This is another way of doing it. If you had more, this is the way I gave here. It would be better if you have a lot more flip calls. Yeah, if there's only 1,000 of them, then you can use an unordered set of the things you've already grabbed. So I did this wrong. That's okay. It still works. Alright. Thank you for watching. Talk to you soon. Have a good rest of your day. I think we're going to grab, there's a few other problems I've already looked at that I'm going to just kind of code them here, but I'm a little bit upset, irritated, annoyed that I made a mistake when coding this and just didn't test enough things to see it. That's really annoying too. Alright, take care.